22, okay, that's what I wanted to go over. Now this one's a little bit different. Now, how many of you have read your sections? Okay, so you know that asymptotes aren't really just where the bottom is 0. Don't you know that? Yes? What happens at a vertical asymptote that is different from a hole? What is a vertical asymptote? What makes a vertical asymptote? Well, no, that's not what makes a vertical asymptote. Doesn't mean you can't plug a number in for that.
You won't ever touch that number.
Okay, so what type of line is a vertical what happens around a vertical asymptote? So here's a vertical asymptote. What will the graph look like around that vertical? It'll get closer and closer and closer to it without touching it, right? Okay, what is the only way to do that? What type of behavior happens? Unbounded behavior is the only type of behavior that can happen near an asymptote. Because if it's a hole, you never approach an asymptote, a vertical asymptote, you never approach it like this. You would never, ever in a graph see a vertical asymptote being approached by a function like that and then skipping over it and then doing something else. That line would not be a vertical asymptote. What would it be instead? It would be a hole. That x value would simply be a hole. It would no longer be a vertical asymptote. So the only way to have an asymptote is for there to be unbounded behavior as x gets toward that number. Okay? So when you're trying to find out where there's an asymptote, the way I told you is probably the easiest way, but it doesn't always work out that way. Because if I just set the bottom equal to 0, right, what do you get? Where do you think an asymptote is? X equals -1. But then many of you probably said, well, that cancels with that x plus 1, and therefore it's removable, so it's just a hole. Seriously, what are you left with when you cross that out? Please pronounce that as the word that you see. Sin. Sine is spelled S-I-N-E, by the way. So you're left with the sin. This is not an algebra move that you can ever make. So this doesn't cancel. It's not a hole. Okay? Now, if we would look at what would be, well, we can't tell that it's a hole, but we also can't tell that we don't know if it's a hole. We can't tell that it's a vertical asymptote right now. Okay? So when I say that we can't cancel that, it doesn't mean that it's not necessarily a hole. X equals 1 is it's a point of discontinuity in the graph, but we can't tell whether it's an asymptote or a hole. There's no way for you to do algebra on this top part to make this x plus 1 ever cancel. So you can't really tell if it's removable by our normal methods. So I want to go back. What if I found the limit as x goes to -1 from the positive, and the limit as x goes to -1 from the negative? What if I found those limits? How could I find those limits? Plug what into the calculator? I mean, you can say, your calculator's useful, but what the heck are you going to plug into a calculator?
The equation closer and closer to that number from which side?
Make a table. Okay? Make a table. Okay? So we want to make a table to show this. So we're going to plug in, here's our -1. This is the point in question. Now, the thing is that this will be a hole if both of these numbers are approaching the same thing from both sides. It's a vertical asymptote if this is like if both of these are going to an infinity or negative infinity. It wouldn't matter which one is doing which, and they could both be going to infinity. So what numbers are approaching -1 from below it? -0.9. No, that's -1.1 and -1.01. Is that enough to check? Okay. And -0.9 and -0.99 from above. All right, so get your calculators out, and let's just say the first 3 rows plug in -1.1 and -1.01, and make sure you put it in parentheses and make sure you're in radians, So you're going to have to parenthesis divide and then begin parenthesis when you divide by x plus 1. Parentheses are very important for getting it to work. And the other half of the room, plug in the ones from above. This is from the positive and this is from the negative. Make sure you are in what mode? Okay, so let's back up. Everybody with us? Quit plugging numbers in and worrying about the decimals right now. We need to look at this table. As I plugged, what are these numbers getting closer to? 1, and these numbers are also getting closer to. So the answer to the question, what is the limit as x goes to -1 is 1. Now, why are we doing a limit problem when it just says name if whether or not x equals -1 is a vertical asymptote? Because believe it or not, continuity, vertical asymptotes, holes, and limits are all very, very much connected. In order to be an asymptote, a vertical asymptote, the limits there will be unbounded behavior. The one-sided limits will be infinity or negative infinity. So this, x equals -1, cannot possibly be a vertical asymptote. Because from above and below 1, we're approaching the same number. Okay, but then again, you look at the function, you can't put -1 in here. It's not defined there. So what would happen at -1? Would it be this situation or this situation? Second situation. So what is this? No, it's not that. You kind of combined asymptote and hole, and it sounds like you called them a bad name. An asymptote. It's a hole. Now, what do they call it? But in the directions here, didn't they say removable discontinuity? Did you know that a hole is a removable discontinuity and they're the same thing? Yeah. So you could call it a hole. It's a removable discontinuity. All right, what other question can I work out? Problem. Which one? 22. Let me guess, it's the long factoring one you didn't feel like factoring. And then next you're going to ask me about 25 because nobody wanted to factor that one. Is that right?
I thought 25 was easy to make.
Okay, good. So tell me what you did to find the vertical asymptotes. Now, you're not going to run that, what we just had to do, you don't run into very often having to do with the vertical asymptotes or the holes. Okay? Usually we can just do our normal, you know, what would we do here to find any vertical asymptotes or holes? What's just overall, what do we have to do with the bottom and the top? Factor. And then what are we going to do with the bottom to find out? Okay, what is setting the bottom equal to 0 and solving it? What does that actually tell us? No, it doesn't tell us where the asymptotes are. It can. We don't just get the asymptotes by setting the bottom equal to 0. Because what else could they be? They could be holes. So by setting the bottom equal to 0, that tells us all possible discontinuities. That's what setting the bottom equal to 0 and solving it does. Okay, that just tells us all the things that we could put in and end up with 0 on the bottom. All possible discontinuities is setting the bottom equal to 0. Okay, so how are we going to solve that? Yeah, how are we going to do that? Take an x out first. How about we take an x out of everything first, GCF. And then we're going to do factor by grouping, and then we're still not even done. We don't need to do the top. This is still just the bottom that we're not done with. All right, so on the bottom, factor by grouping means I group it in 2 pairs. This is the second type of factoring you learned in Algebra 1. What can I take out of these two? X squared. Inside I have x minus 2. What can I take out of these two? 9, and inside I have x minus 2. Why is it plus? Why is it?
Because a negative and a negative equals a positive.
Yes. Okay, now we're not done. Now finish factoring. How does this inside part factor?
That's minus 3x plus x.
No, hold on. X squared minus 9 and x minus 2. But doesn't x squared minus 9 factor more? How does that factor?
X plus 3x.
Okay, it doesn't matter what order you put them in. It's the same as plus, minus, minus, plus. Okay, now what are my possible discontinuities?
Plus and minus 0.
X equals 0, x equals 3, x equals negative 3, x equals 2. Okay, you can't just say they're all asymptotes. The only ones that are asymptotes are the ones that won't cancel now. So now I have to go back up and factor the top and see if there are any parentheses on the top that match those. So how do I factor the top? What can I factor it to pull out of everything? A 4, and inside I have x squared plus x minus 6. And then how does that factor? Okay, so I'm going to write that right down here. So if you've got a 4, and then you've got an x plus 3 and an x minus 2. Does that cancel with any of those?
Yeah.
So these cancel, these cancel. So what are these two things? Those two things are wholes because they canceled, which means that it's going to be going to the same number from both sides. And these two are going to be vertical asymptotes. That's what typically happens. Now I think that if you were to go through and find the limits, the limit is x goes to negative 3, the limit is x goes to 2, that you'd find that you'd be able to plug those numbers in and it would work out after you simplified it. For these two, you would get like infinity or negative infinity for your limits. So that's how you separate them. All of those are called possible discontinuities. The ones that cancel are the wholes. The ones that are vertical asymptotes don't cancel. Will you have to know that on the test? Yes, you will. All right, what else? Yes. 8. Okay, so you were plugging numbers in?
Yeah, I just didn't know how to understand numbers. Like, I got negative 1 for all of them, so I didn't know.
Okay, were you plugging in like this? Begin parentheses. You sure? Okay, but you don't have a secant button on your calculator, so how were you doing that?
So I
You were taking 1 divided by the cosine of... Some of you are taking the reciprocal of this. That's like so wrong. There's nothing correct about that. Taking the reciprocal of that is not even an angle on the unit circle anymore or anywhere near it. Is that what you were doing wrong?
No, I put sine instead of cosine because
Okay. I mean, that's literally, I'm not going to go through and plug all those into a calc. Yeah, okay.
no, I understand.
All right, anything else? What else? One more questions. What do you always try first? Substitution, okay. Even if it's a one-sided limit, do you try that first? Yeah, you do. I would try substitution every time first. Okay, what does 0 over 0 tell you? It's what called what form? Indeterminate. And what does that mean? It means do some algebra and then try substitution again. Do some algebra and then sub again. Okay, tell me, quit trying to hand your papers in yet, just sit and listen for a minute. Okay, what if you get something like 5 over 0? What does that mean?
That's,
Yeah, this is undefined, but if you're finding a limit and you use substitution and get this, what does that actually mean? No, it doesn't mean you have to use algebra. It means that you're okay, what, by a vertical asymptote, what's the limit? No, to one side, well, okay, it could be does not exist.